Okay, well, I'll have to call you back. No, I'll call you back. Trust me, okay? I'll call you back. All right, bye-bye. Hi, and welcome to the Math Shop, where mathematics is a way of life. Really. I'm Christine, and this is my Math Shop partner, Kanwal.
Hi. We're here to help you with this puzzling, fascinating, and very useful subject. We want to show you that you can do math too.
Right, and if anyone can show you that, Kanwal can, because he's a really good teacher. And really humble, too. Of course, we'll be assisted by my creation, Euclid. Now, this is my homemade, only slightly off the wall, and immensely powerful computer. Say hello to the audience. Euclid? Thank you. Today on Math Shop, we want to look at the question of math anxiety and also deal with some fundamentals like number sets, reciprocals, and basic operations with positive and negative numbers.
But first, we wanted to find out what you think about mathematics.
Right. So, Euclid, roll clip 1.
I get scared.
Partly because I've probably been socialized as a female that I don't think linearly, and I'm not prone to thinking mathematically, and I'm not rational. And I get scared. I'm paranoid.
It's pretty scary because I actually at school I was pretty bad at it. So
it's kind of neat because it's like solving problems, you know, and challenging and really satisfying when you actually solve one.
Like, to put a little bit more fun into it, we'd accept learning it better than the way it's so stinking boring. Okay, you just put a whole bunch of numbers on the board and then, okay, that's it, class over, do your homework.
It seems to me that it was always difficult for me, and I felt that I needed help, and I didn't get it. And I'm very disappointed I didn't, because I think it's very important.
Yeah, I dropped math in grade 11 because the teacher asked me to.
Math always seemed to be like the most difficult subject to do, I think. For a lot of people, it seemed that way. So it was always negative that way because it was, you know, a certain amount of fear was always involved with taking math classes.
I was anxious, I guess, through pressure from my parents. And they said, oh, you have to do well in math. That's the most important subject. And in terms of at school, you heard that the math teachers were the worst. And
D? D and C minus, that's what I get them every time, so.
Mathematics to me was interesting because it was just always like a puzzle, you know, and puzzles are fun, eh?
I hate it because I'm doing it right now in school and I hate it.
To tell you the truth, once I got a grasp of math, it was just, I looked forward to it. History and geography, kiss it goodbye. But give me my math. Figures are fun.
I mean, in math, you need a lot of practice. If you do a lot of problems, then you will do well in the exams.
Scary. Because I didn't do well at school.
My times tables. I got stressed on the 7s. That was it. I remember that well. I still have a problem with that one.
Well, as you can see, a lot of people are put on edge by mathematics. Yes, Kanwal.
But Christine, you didn't ask me.
Okay, just for the record, Kanwal, do you ever feel nervous about math?
Yeah, but if someone gives me a certain kind of problem I haven't done for a while, I may not remember the right way to do it. Then I feel a bit nervous.
Really?
Yeah.
Oh, so even people who work with math every day can feel nervous or uncertain about it. So to get some ideas on how to cope with math anxiety, we went to go talk to Tom O'Shea. Now, Tom is a mathematics educator at Simon Fraser University. Euclid, roll clip 2.
Typical symptoms of math anxiety are, well, there's a broad range of symptoms. They can range from very severe manifestations, where the person breaks into a cold sweat, has feelings of panic, and very severe reactions, down to a discomfort, a general discomfort with the idea of doing mathematics. Math anxiety can be related to unpleasant experiences in our early development, such as embarrassments, being called upon in school to do a mathematics problem and not being not being prepared for it, and perhaps being embarrassed by having to go up, and maybe comments by students or teachers. The family can also be responsible, where families put on a lot of pressure for students to perform well in mathematics, and if they don't, they may be labeled as stupid or lazy or whatever. And this may be particularly the case in families where the parents are good mathematically and are very disappointed in children that don't show the same talent as they do. Math anxiety may result from the individual desire to be perfect. People think that if you can't do everything perfectly, including mathematics, that there's something wrong with you. I mean, the most, I suppose, telling example of this is playing chess. People put a lot of their own ego in their success in chess, and I think that much of that happens in doing mathematics as well. For those people that have to contend with severe math anxiety, one of the ways of coping is to go into relaxation strategies. One of the best relaxation strategies is deep breathing. So, for example, if you're having a feeling of panic, sit back, take a deep breath, and sigh as you exhale. And just feel the relaxation come over you. Do that a few times. Perhaps do some exercises and try to put yourself into a calmer frame of mind. I think one of the key things is to start. When you're faced with a mathematics problem, you need to reflect on it. You need to think about it. You need to look at all aspects of it. If it's a mathematics word problem of some kind, think about rephrasing it in your own mind. What does it mean? What is wanted? What have you got to work from? Then the next thing is to do something. Put something down on paper. Even if you start doodling, risk making a commitment to the problem. Once you get started, then it's easier to keep going. One of the great blocks is the inability to even begin to get going on a problem. And the final step in solving problems is to, once you've got your solution, to react to it in some way. You just don't stop at that point. You look at your solution, you decide whether it ties in with the original data, whether it makes sense, whether it connects to the estimates that you've made of what the answer should be. Another way of dealing with math anxiety is to recognize that you can't do everything on your own. That the time comes when you need to seek support from other people, and you may want to engage a partner in learning or get a group going to tackle the problem. One of the other things you can do is to take a break. Go and do something else. Watch television for a while. Get your mind off the problem. Come back to it later. You'll have a fresh frame of mind, and you'll be much better able to deal with it. And I think one of the key aspects of it is to think positively about yourself and your mathematics ability. Reinforce your positive thinking. Make little notes. Put them in your bathroom in the morning. To put them on the mirror. I'm good in math. I can do math. Recall your successes in mathematics. Visualize yourself as a good mathematician. When you go to sleep at night, think to yourself how good you are and how successful you're going to be the next day, and try to change their whole way of thinking from a negative kind of mode into a very positive way. You can deal with math anxiety as well by maintaining a journal. Keep a log, a diary of the things that work for you, of shortcuts to doing mathematics, of things that you've learned about it, of typical word problems perhaps and their solutions, of strategies that have worked for you. So I guess the moral to the story is, regardless of how you feel about mathematics, you may feel anxious about it, you may feel reluctant to start, the moral of the story is, do it. It's just a matter of working at it.
So, the message is, mathematics may be difficult, but don't give up. There are many ways of making it work for you instead of against you.
I think that what Tom said about coping with math was really important. Christine, maybe we could review that?
Sure, yeah, no problem. Euclid, run summary. Euclid. Must have been a loose chip. Okay, remember, when you're getting nervous about math, just sit back for a minute. Take your time and try to figure out what is being asked. Then go ahead and risk it. Try something. What have you got to lose? If you're stuck, go make a cup of tea or put in a load of laundry. Use your break for some relaxation strategies if you feel you need to. If you can, get a learning partner, and you know, it doesn't need to be another student. And as you start to figure out a few things, jot them down in a notebook. It doesn't matter what you put in there. No one else is going to see it, but just write down any little tricks or shortcuts you pick up, any pages of text that you may find important, anything that could be of use to you as you go further into the, well, not so scary world of math.
That's great, Christine. Good advice.
Thanks, Kanwal. And now Kanwal's going to talk to you about something that's as basic to math as eggs are to omelets, and that's numbers. So, take it away, Kanwal.
Thank you.
Oh, wait a minute. I forgot to give you something. Here we go. I almost forgot. Now, would you believe that every real number in the entire universe is in this little box?
Oh, thank you, Christine.
No problem.
The real numbers are made up of various sets of numbers. Let's investigate them. Natural numbers or counting numbers form the earliest, simplest attempt at numbering. Natural numbers.
Natural numbers.
Whole numbers consist of the natural numbers and zero. Whole numbers.
Whole numbers.
Integers include whole numbers and negative counting numbers. Integers.
Integers.
Rational numbers are those which can be expressed as a ratio or as a fraction. For example, 1/2 is a fraction, therefore it is a rational number. Another example is -2 3/4. It is a mixed number consisting of an integer and a fraction. It is also an example of a rational number. Decimals are also part of rational numbers and include terminating and repeating decimals. An example of a terminating decimal is 3.59. It has a finite number of digits, whereas -15.3 repeating is an example of a repeating decimal because the decimal follows a pattern and does not end. Rational numbers.
Rational numbers.
And finally, irrational numbers, which cannot be expressed as a ratio or as a fraction, and if expressed as a decimal, doesn't end and doesn't repeat. For example, square root of 2 is 1.414. The decimal neither ends nor repeats. Irrational numbers.
Irrational numbers.
Just to give you another example of an irrational number, this is pi. Rounded off to 2 decimal places, it is 3.14. But worked out to 1,000 places...
As you can see, there's no pattern to the digits and no way to predict what the next digit will be. Oh, it's long, and mathematicians have proved that it really could go on forever. Computers have calculated pi to hundreds of thousands of digits, and if there was enough time, they could take it to millions or even billions of digits without terminating or repeating the pattern.
So this 1,000 digits is just a piece of pi?
Yeah, but it's no piece of cake. Okay, Kanwal, summarize, please.
Okay. The natural numbers fit in the set of whole numbers. The whole numbers fit in the set of integers. The integers fit in the set of rational numbers. The irrational numbers are a distinct set, but together they all give us the set of real numbers.
Euclid, give me a number line. Okay. Now a number line is just what it says, a line with numbers on it. And we see variations of it in real life all the time. For example, when we check the temperature on a thermometer, when we measure something with a ruler, or when we look at the speedometer of a car, and in other places too. In mathematics, though, unlike the speedometer of your car, the number line has no limit. It contains an infinite number of numbers, and we can use it to demonstrate some interesting things about the way numbers work. 0 serves as a central point, and that produces a very interesting symmetry. Look, on one side of 0, we have positive 1. On the other side of 0, we have negative 1. If we add them together, we get 0. If we take positive 2 and negative 2 and add them together, we get 0. Positive 3, negative 3, same thing, 0. So, every number on the number line has an opposite. And opposites are numbers which, when added together, equal 0. We'll be using opposites a lot when we start solving equations later on in the series. The other number on the number line, which is very important, is 1. Now, 1 may not sound very important, but when we get into algebra, it becomes absolutely essential. It's at the heart of a very important concept, something called the reciprocal. Kanwal?
Every rational number has a reciprocal. Equations can be simplified through the use of the reciprocal. That's why it's so important. Now, the integer 2 can be expressed as a rational, as 2 over 1. Its reciprocal is 1/2. When I multiply the reciprocals, I get 2 over 2, which equals 1. Note that any number multiplied by its reciprocal is equal to 1. Let's do another example. 3/5. This is a proper fraction because the numerator is less than the denominator. Its reciprocal is 5 over 3, which is an improper fraction because the numerator is larger than the denominator. When I multiply the reciprocals together, once again, they equal 1. Another example is 2 1/3. This is a mixed number, but before I find its reciprocal, I must change it to an improper fraction, which is 7 over 3. Now, once again, if I multiply 7 over 3 by its reciprocal, 3 over 7, this equals 1 also.
Reciprocals, like opposites, are going to be very useful to you later on. And you should know that if you have the right calculator, it will actually work out the reciprocals for you. There are so many different kinds of calculators on the market these days that it's easy to get confused when you shop for one. Well, we've done some research for you. And for the level of math we're doing here on Math Shop, we recommend this. This is a scientific calculator, which has all the features you'll need for the work you'll do with us, and it's reasonably priced. Of course, you don't have to get this exact model, but if you do get something else, make sure that it has all of the following features: sine, cosine, tangent, y to the x, or sometimes x to the y, the plus-minus key, and 1 over x. As you saw, 2 of the features listed are a plus-minus key and a 1 over x key. Now, if you've never used any of these keys before, here's an explanation.
Let's deal with the 1 over x key first. As you saw before, finding the reciprocal of a fraction is fairly easy. Finding the reciprocal of a decimal, if you use a calculator, is just as easy. Using the 1 over x key, you can generate the reciprocal of a decimal. For example, decimal 1/5. I press decimal 1/5. To get its reciprocal, I press the 1 over x key, and I get the reciprocal 6.6 repeating, or the calculator rounds off the last digit to 7. The reciprocal of a number will be very useful when we start solving equations. As Christine said, the plus-minus key is also useful. But before I can talk about that, we need to talk about operations with signed numbers.
Right, operations. In math, the way the numbers interact is called operations. And in school, we all learned the basic operations of addition, subtraction, multiplication, and division with whole numbers. Now, in the set of integers, though, there are a few important rules about the signs of numbers which affect the operations.
To better explain this, I'm going to use these colored chips. The green represent positive integers, the red the negative integers. Let's take a look at an example. Positive 2 plus negative 5. To start with, I have 2 green chips, and I add 5 red chips. Now, if you recall, when we were doing opposites, a positive and a negative is equal to 0, so I take that away, but it doesn't change the value of my question. Here is another 0. I'm left with 3 red chips, or my answer is -3. Let's look at another example. -3 plus -4. This time I start with 3 red chips, but now I'm adding 4 red chips to this. This time I don't have any zeros, but I have got 7 red chips. My answer is -7. Let's take a look at a subtraction question. -5 minus +4. This time I start with 5 red chips, and I'm supposed to take away 4 green chips. I can't do that. But what I'm going to do is add 4 zeros. Now, adding 4 zeros does not change the value of my question. But now I can take away 4 green chips, which leaves me with 9 red chips, so my answer is -9. Let's take a look at one final example for subtraction. +3 minus -4. Now I start with 3 green chips, and I'm supposed to take away 4 red chips, but there are no red chips there to take away, so let's add our zeros. Once again, I can take away the 4 red chips. I'm left with 7 green chips, and my answer is +7. Remember that whenever you're faced with the subtraction of a negative number, you can add the 2 numbers. Now, let's use these chips in a different way to look at the operation of multiplication. This will also help you remember the rules for multiplication. For example, +2 times +3. Now, I start with a rectangle 2 by 3. Since this is +2, I don't do anything to the chips, and this is also +3. I don't do anything to the chips. My answer is the 6 green chips, or +6. Let's look at another example. -2 times +3. Once again, I have a rectangle 2 by 3. But this time, this is -2. Whenever you have a negative number, you flip the chips once. So this is negative, so I flip them. But this is +3, so I don't do anything, and this is my answer, the 6 red chips, or -6. Let's look at one final example. -3 times -2. This time, I have, once again, starting with a 3 by 2. But now this is -3, so I flip them once. But this is also negative, so I have to flip them one more time. And I end up with 6 green chips, or my answer is +6. Remember, if the signs are the same, the answer is positive. If the signs are different, the answer is negative. The same rules apply for division as for multiplication. And now that we've covered the rules of operations with sign numbers, we can go back to look at the +- key on the calculator. Here's an example. -7 minus -10. I'm going to do this in a couple of ways. First, I'm going to use the chips once again. I start with 7 red chips. I'm supposed to take away 10 red chips, but I can't do that, so once again, I enter 3 zeros, and now I have 10 red chips that I can take away, and I'm left with 3 green chips, and my answer is +3. Let's do this on the calculator. I start off by entering -7, subtract -10. My answer is, oops, I got -17, which is not the correct answer. The reason why I did not get the correct answer is I did not use the plus minus key to enter negative integers. Let's do it one more time. This time, in order to enter -7, I will enter 7, followed by the plus minus key, which also displays -7 now. Then the subtraction key, followed by, in order to enter -10, I enter 10, then the plus minus key. Now to get the answer, I press equal to. Now I get an answer of 3, which was the correct answer. Remember, in order to enter negative integers on the calculator, you must use the plus minus key.
Thanks, Kanwal. Well, that's all the time we have on Math Shop today. We hope you enjoyed it. And come and see us again. And remember, math is not cruel and unusual punishment. It's just part of everyday life.
Goodbye. Thanks for watching.
Bye.
Christine, what are you doing? Placing a call to Tasmania or Mars or something?
No.
Then how come you're dialing so many digits?
Oh, because this guy left me his irrational phone number.